Are you able to view the screen?
Yes, ma'am.
So this is a given question. X of t is u of t minus u of t minus 3, whereas h of t is u of t minus u of t minus 2. We have to find the convolution integral y of t, okay, which is the convolution of x of t and h of t, okay. So y of t is the convolution of x of t convolved with h of t. So y of t, what is the equation for convolution integral?
Integral minus infinity to infinity x of tau
X
into
of tau into
h
h
of
of
t minus
t
tau.
minus tau into d tau, right? So this is the convolution integral equation. So now we'll substitute the values of x of tau and h of t minus tau. In place of x of tau, we'll replace the term x of t, the terms of x of t, by replacing t with tau, whereas for h of t minus tau, we'll replace the h of t term with t minus tau. Wherever you have t, replace it with t minus tau. So y of t would be integral minus infinity to infinity u of tau minus u of t minus, sorry, tau minus 3, u of tau minus 3 into u of t minus tau into u of t minus tau minus 2. Okay, did you all understand how we got this equation? We are replacing x of t, this term x of t with tau. We get u of tau minus u of tau minus 3, and in h of t term we are replacing t with t minus tau. Okay, we get this. So we have to do this multiplication, u of tau minus u of tau minus 3 into u of t minus tau into u of t minus tau minus 2. So we have to plot this graphically. Okay, so we'll try plotting this. This is one term and this is one term. So x of tau is quite easy, right? So it's u of tau minus u of tau minus 3. It's nothing but u of t minus u of t minus 3. So the signal will exist from 0 to 3. So this is x of tau. 1, 2, 3 with an amplitude 1. Okay, this is your x of tau. And we have to plot u of tau, t minus tau into u of t minus tau minus 2. So let us plot h of tau first. Okay, what is h of tau? U of tau minus u of tau minus 2. Then we'll take the, we'll do shifting to get h of t minus tau. So we have h of tau, which is nothing but u of t minus u of t minus 2, which is nothing but u of tau minus u of tau minus 2. So it will exist from 0 to 2 with an amplitude 1. Now how will you plot h of t minus tau?
Ma'am, we will shift the curve from 0 to tau, then 2 to tau plus 2, ma'am.
Okay, let us see. So h of tau we have got. We have to plot h of t minus tau. So to get h of t minus tau, first you plot h of t tau plus t. Okay. Here t is your constant. Okay. So let us plot h of tau plus t or t plus tau. So that would be tau plus t, it would be existing from, so this is 2 units, right? So the width of this h of tau is 2 units. So we have to maintain that 2 units and we have to plot h of tau plus t. So h of tau plus t would be from t to t plus 2. So let us check if our width of 2 units is maintained. If t is equal to minus 1, t plus 2 would be minus 1 plus 2, it would be 1. So this, if your t is at minus 1, then t plus 2 would be at 1. So our width of 2 units is maintained. Okay, suppose your t is at minus 2. So t plus 2 would be at minus 2 plus 2, it will be at 0. Okay, so we are maintaining the width of 2 units uniformly. So now take this reflection, h of t plus tau we have got, or h of tau plus t. Let us now take t minus tau. Okay, to get this h of t minus tau term. So that would be reversal of that. H h of t plus tau. So h of t minus tau would be t minus 2 to t. Okay, t minus 2 to t. Again, just check whether the width of 2 units is maintained. Okay, so whenever you have such if you have such finite signal like this, you take like this. Okay, take, if from 0 to 2, if you have, you take t plus 2, so that 2 units is maintained. Then you take time reversal of that, you'll get t minus 2 to t. It depends on this width. Okay, so t minus 2 to t we have taken. So let us check if the width of 2 units is maintained here also. So if t is at 1, t minus 2 would be at 1 minus 2, that is minus 1, right? So our width of 2 units is maintained. So next I'll take t is equal to 2. If t is equal to 2, t minus 2 would be at 2 minus 2, that t minus 2 term will be at 0. Okay, so we can see that our width of 2 units is maintained. So this is our waveforms of interest, h of t minus tau and x of tau. Okay, so now let us start convolving those two signals. So both are finite signals, right? We have to fix one signal and we have to vary the other signal. Let us fix x of tau and vary h of t minus tau. So convolution is fixing one waveform and varying the other waveform with respect to the first waveform. Okay, so let us see the convolution. So case 1. So we are fixing x of t or x of tau and we are varying h of t minus tau. So x of tau lies between 0 to 3, 0, 1, 2 and 3, and h of t minus tau, let us take the case first. So case 1 is when your t is less than 0. Okay, when t is less than 0, it will be from here to here. This would be t, then this would be t minus 2. So what is the overlapping space? There is no overlapping space, right? So y of t would be equal to 0. Next case, understood everyone? You are following?
Yes, ma'am.
Yes, ma'am. Okay. So take next case, case 2. So the case 2, t is between 0 and 2. Let us take the case t between 0 and 2. So 0 less than or equal to t less than or equal to 2. So this is our next case. So this is our x of tau and we have 1, 2 and 3. So let our t be between 0 and 2. Suppose 0 to 2, let it be between 1 and 2. So I'll assume it's 1.5. So where will this is t is between 0 to 2. I'll take t is at 1.5. Where will your t minus 2 be? 1.5 minus 2, it will be at minus 0.5, correct? So it will be at this t minus 2. If for example I'm telling you, if t is 1.5, t minus 2 will be at minus 0.5. Yes or no? So now what is the overlapping space you check? Okay, this is the first case. Second case is t between 0 to 2. For example, I'll take it 1.5. So if t is at 1.5, check where is t minus 2. It is at minus 0.5. Okay, it is somewhere here. So what is the overlapping space you check? This is the overlapping space from 0 to t. So write your integral y of t, which is equal to 0 to t. So here you don't have any term here. All are 1 only. Unit step 1 into 1. So you have 1. 0 to t, 1 into d tau. So if you integrate 1 with respect to d tau, what do you get? You get tau with limit 0 to t. So your y of t would be equal to t. Got it, everyone? Is it clear?
Yes, ma'am.
What about others? Clear?
Ma'am, we can choose 0 to 1 now, ma'am.
Yeah, you take 0 to 1 also. Between 0 to 2, anywhere. If
No, ma'am.
t is
How
at
to
1,
consider that? Hello, ma'am.
Yes.
How to consider that interval as 0 to 2, ma'am? We can also take 0 to 1, no, ma'am, interval for case 2.
See, first let your t be less than 0, then let it be for two intervals you have to be t should be inside this x of t. Okay, so first I have taken first case from 0 to 2, and next case I'll take t from 2 to 3, or you can take 0 to 1, you can take t between 0 to 1, next you take between 2 and 3. Two instances is enough. Okay, next you take t greater than 3. Got it? And t
Okay,
minus
ma'am.
2, which is less than 3. So you'll cover all the
2
cases.
instances is enough, no, ma'am?
Yes?
2 instances is enough, no, ma'am, for overlapping.
Yeah, you can take t between, you have 3 units here, right? So you take 2 instances between 0 to 2 and between 2 and 3, t. What happens? Okay, if your t is sliding over this h of t minus tau is sliding over this x of tau, so we are checking the instances, whatever we get. Okay, convolution integral, convolution of these two signals. If you want, you can take between t between 0 to 1 also. Next case, you take between 1 to 3, t between 1 and 3. Okay, you can take. So let first case let t be less than 0. Next, let t be between t be between, for two instances, let it be in this only, x of tau only. Next, you take t greater than 3, t minus 2 between this. Yeah, it will be inside this x of tau. Then both t minus 2 and t greater than 3 you take. Last case. Got it? 5 cases. Clear?
Yes, ma'am.
Okay. Case 3 you take where
Ma'am, we can take more than 2 also, no, ma'am?
where
Here we can take 3 possibilities, no, ma'am. 0 to 1, 1 to 2, 2 to 3.
this would be enough. 2 possibilities are enough. If you take 3, then you will get 6 cases, no?
Yes, ma'am.
5 cases are enough. Okay.
Okay, ma'am. If I take also, there is no problem, ma'am.
Don't take better. You take 2 cases, enough. Okay.
Okay, ma'am.
So next, I'm assuming my t is between 2 and 3. Next case. Okay. So this is x of tau 1, 2, 3. Now I'm assuming t is between 2 and 3. That is, I'll assume it as a 2.5. My t. So what would be t minus 2? T minus 2 would be 2.5 minus 2. So t minus 2 will be at 0.5. Right? It will be here. Correct? So what is the overlapping space?
0.5 to t.
No, 0.5 is just an example. So t is equal to 2.5 is just an example I took. So if t is between 2 and 3, t minus 2 is between 0 and 1. So what is the overlapping space?
T minus 2 to t.
T minus 2 to t. So 2.5, 0.5 are just examples. You can take anything. You can take 2.1. Between 2 and 3, you can take any value. Just I've told you one example, 2.5. Okay. So we have t, integral t minus 2 to t, 1 into d tau. Okay. So if you integrate 1 with respect to d tau, you get tau with limits t and t minus 2. So upper limit minus lower limit would be t minus of t minus 2, which is nothing but t minus t plus 2. T and t gets cancelled. Your y of t will be equal to 2. Got it, everyone? Clear? Clear, guys?
Yes, ma'am.
So now you take case 4 where t has crossed 3. Okay. T is greater than 3 you take. Next case. Case 4 when t is greater than 3 and t minus 2 is less than 3. It might be any value. So 0, 1, 2, 3. So t is somewhere here. So suppose if your t is at 4, t minus 2 will be at 4 minus 2, it will be at 2. So this is the overlapping space. So what is the overlapping space? Here you have t, here you have t minus 2. What is the overlapping space?
T
T
minus
minus 2 to 3.
Yes. So you have y of t, which is equal to t minus 2 to 3, 1 into d tau. So you get tau with limits 3 and t minus 2. So if you put upper limit minus lower limit, you have 3 minus t minus 2, which is equal to 3 minus t plus 2, which is equal to 5 minus t. Got it? Clear? Clear, everyone?
Yes, ma'am.
Yes, ma'am.
T has crossed that 3. Okay, instant 3. T is beyond this 3, whereas t minus 2 is less than 3. So that time you can see the overlapping space to be t minus 2 to 3 only. That is only the overlapping space. So that we have taken the limits of integral as t minus 2 to 3. Now next case, when t is also greater than 3 and t minus 2 is also greater than 3. So it has exceeded that instant 3. So it is like this somewhere, t and t minus 2. Both are greater than 3. Okay. This is x of tau into h of t minus tau. So what is the overlapping space? There is no overlapping space. So you can take it as 0. Okay. So this is how you have to do the graphical convolution. So you have to you have to know the width of these both h of tau and h of t minus tau, fix one waveform and vary the another waveform using the 2 pointers. You take these 2 pointers t minus 2 and t, vary with respect to that pointers. Okay. So what was your y of t? For case 1, it was 0 when t is less than 0. For case 2, it was t when t was between 0 to 2. Then it was 2 when your t was between 2 and 3. Then you had 5 minus t when your t was greater than 3 and t minus 2 was less than 3. Correct? And you have 0, last case, when t is greater than 3 as well as t minus 2 is also greater than 3. Got it, everyone?
Ma'am, for fourth condition, ma'am, can we take 3 less than or equal to t less than or equal to 5, ma'am?
Which one?
For fourth condition.
Fourth condition, yes. What will you take?
3 less than or equal to t less than or equal to 5.
5 you will take. What is 5?
If we shift, we will get the same, no, ma'am.
So you're telling t equal to 3.
No, ma'am.
Okay, t minus 2.
Equal to t.
Come again. So you're telling t
3
is
less
equal to 3.
No, 3 less than or equal to t less than or equal to 5.
3 less than or equal to t
Less than or equal to 5.
5. See, why you're taking 0 to 3 here? Because we have x of t from 0 to 3. What is this 5? No need to mention these values. Random values don't take random values. Okay?
No, ma'am. If we add both the signal, we will get maximum 5 only, no, ma'am. But in fourth case also we do the same.
So you're telling me you want to take t is equal to 3 or t minus 2 is equal to 3.
No, ma'am. In between 3 and 5.
That case is for case number 4 only, no?
Yes, ma'am.
T is greater than 3, t minus 2 is less than 3. That is case number 3 only, which you are telling.
Yes, ma'am. For that only.
So what is yes?
The range will be that only, no, ma'am. Between 3 and 5.
Will you get the limits the same if you take like that?
Yes, ma'am.
Yes, you can take that. You are important. What you have to concentrate is limits only. How to get the limits properly.
Okay.
If you get the limits between t minus 2 and 3, you can take.
Yes, ma'am.
Okay guys, so that is about convolution integral. We'll solve some more problems. So in convolution sum, there is one property method. Okay, so we shall see that. So in convolution, you have different properties. Okay, commutative property, associative property, distributive property, property of delta function and all. We shall see that. So there is one property which using which you will solve convolution sum problems. Okay, so that is convolution of two delayed unit impulse signals sequences. So if you have two delayed unit impulse sequences, that is delta of n minus m convolved with delta of n minus k. So convolution of these two would result in delta of n minus m plus k. Okay, which is nothing but delta of n minus m minus k. Got it? So this is a convolution of two delayed unit impulse sequences. If you convolve these two, you'll get a delayed function. These delays will be added together. This delay and this delay. Fine. So let us see the convolution sum, how to plot the convolution sum using these sequences. Okay. So take down a question. We had solved one question, right? Determine the convolution sum of the given sequence. I showed you one simple method, right? Determine the discrete time convolution of two sequences. So you will be given with x of n, which is 1, 2, 3 and 4. Your origin is at 2. Okay, and h of n is given to be 1, 5 and 1, and your origin is at 5. Did we solve this problem, right? You people remember using that simple method I solved? You remember that?
Yes, ma'am.
Yes, ma'am.
Can you tell me the output of that? Y of n?
1, 7, 14, 21, 3, 4.
Hello students, am I audible?
Yes.
Yes, ma'am.
Yes, ma'am.
Yeah. So it will take time to load. I'll show you this PDF. Okay, you can follow. So we have convolution of two given sequences. We have to find the convolution using the property method. Okay, if you have two delta functions, then the convolution of those two would be the sum of the delays. Okay, are you able to view the screen, everyone?
Yes, ma'am.
Are you able to see everyone? No issues?
Yes, ma'am.
Okay, so we'll take, this is one problem. So let that problem which I have given you, you do that using this method what I teach you now. So x of n is given to be 1, 2, 3, 4, your origin is at 2. Okay, whereas h of n is 1, 1, 3, 2 and origin is at 1. Okay. So I can write x of n as shifted version of impulse responses, right? We had seen that in our convolution sum. So x of n is equal to 1, 2, 3, 4. And the origin, so at n is equal to 0, the amplitude is 2, correct? That is the meaning of this. So at -1 you have 1, at 1 you have 3, and at 2 you have 4. So I can write x of n as delta n plus 1 plus 2 times delta n plus 3 times delta n minus 1 plus 4. Or no? Can I write like this? Am I audible?
Yes, ma'am.
Yes, ma'am.
So x of n can be written as delta n plus 1 plus 2 times delta n plus 3 times delta n minus 1 plus 4 times delta n minus 2. Okay, I can write x of n like this. Whereas h of n also I can write similar way by the shifted version of impulse responses. So origin is at 1. At n is equal to 0, amplitude is 1. So I can write it as delta n plus 1 time delta n minus 1 plus 3 times delta n minus 2 plus 2 times delta n minus 3. Okay. So now we can write x of n and h of n as a shifted version of impulse responses along with our amplitudes. Okay. So let us try to convolve these two. X of n convolved with h of n. So delta of n plus 1, x of n converted with h of n would be delta of n plus 1 plus 2 times delta n plus 3 times delta n minus 1 plus 4 times delta n minus 2 convolved with delta n plus delta n minus 1 plus 3 times delta n minus 2 plus 2 times delta n minus 3. Okay, now you try to multiply each term with the other one. This with all these three. Try to multiply these two sequences. Okay, so if you multiply, what do you get? Delta of n plus 1 into delta of n plus delta of n plus 1 convolved with, delta of n plus 1 convolved with delta n plus delta of n plus 1 convolved with delta of n minus 1 plus delta n plus 1 convolved with 3 times delta n minus 1 plus delta of n plus 1 convolved with 2 times delta n minus 3 plus, take the second term, multiply with all these. So 2 times delta n convolved with delta n plus 2 times delta n convolved with delta n minus 1 plus 2 times delta convolved with 3 times delta n minus 3 plus 2 times delta n convolved with 2 times delta n minus 3. Okay, plus you have this one plus 3 times delta n minus 1 convolved with delta n. Okay, that is what here it's here, plus 3 times delta n minus 1 convolved with delta n plus 3 times delta n minus 1 convolved with delta n minus 1 plus 3 times delta n minus 1 convolved with 3 times delta n minus 2 plus 3 times delta n minus 1 convolved with 2 times delta n minus 3. Okay, and multiply this last term with all these 4 terms so that you will have convolved both the sequences, right? So plus 4 times delta n minus 2 convolved with delta n plus 4 times delta n minus 2 convolved with delta n minus 1 plus 4 times delta n minus 2 convolved with 3 times delta n minus 2 plus 4 times delta n minus 2 convolved with 2 times delta n minus 3. Okay. So now you multiply and write all these terms, whatever you get. So delta of n plus 1 convolved with delta n would be delta of n plus 1 only. Okay. Delta of n plus 1 convolved with delta n minus 1 would be delta of n plus 1 minus 1. Plus 1 minus 1 will get cancelled. You'll have delta n only. Are you guys following?
Yes, ma'am.
So delta n plus 1 convolved with 3 times delta n minus 2 will be 3 times delta n minus 1. Correct? Following amplitude, you multiply 1 and 3 and try to add or subtract this delays. Okay, you have plus 1 minus 2, so that would be 3 times delta n minus 1. Similarly, for this one, delta of n plus 1 convolved with 2 times delta n minus 3 would be 2 times delta n minus 2. Right? 2 times delta n minus 2. Similarly, you try to multiply everything and you will get something like this. So whatever you have n plus 1 term, you solve that n plus 1 term, add or subtract that. Delta n term also you check where are delta n terms, add and subtract. So if you do like that, you will get a sequence like this. Got it, everyone? Clear?
Scroll down.
Followed or not? Yes?
Ma'am, scroll down, ma'am.
See, you understood how to write these things, right? We are convolving each term with all the terms. That is understood. Now you use that property what I showed you. What is that property? If you convolve two sequences, then the resultant would be the summation of the delays. Okay, you have delta n plus 1 convolved with delta n. So that would be delta of n plus 1 plus 0. So that would be delta of n plus 1 only. So next you have delta of n plus 1 convolved with delta of n minus 1. So that would be delta of n plus 1 minus 1. That would be delta n. Okay. Next you have delta of n plus 1 convolved with 3 times delta n minus 2. That would be 3 times delta n minus 1. Plus 1 minus 2 you have 3 times delta n minus 1 you have. Plus delta n plus 1 convolved with 2 times delta n minus 3 would be 2 times delta n minus 2. Okay. And if you convolve 2 times delta n with delta n, you will have 2 times delta n only. Okay. Then you have 2 times delta n convolved with delta n minus 1. That would be 2 times delta n minus 1. Okay. Then you have 2 times delta n convolved with 3 times delta n minus 2. That would be 6 times delta n minus 2. If you convolve these two, multiply the amplitudes and add the delays. Okay. You have delta n here and delta n minus 2. So that would be 6 times delta n minus 2. Okay, that we have here. Next you have delta 2 times delta n converted with 2 times delta n minus 2. That would be 4 times delta n minus 3. Plus, next you have 3 times delta n minus 1 converted with delta n. So that would be 3 times delta n minus 1. Okay, next you have 3 times delta n minus 1 converted with delta n minus 1. So that would be 3 times delta n minus 2. Got it? Plus, you have 3 times delta n minus 1 converted with 3 times delta n minus 2. This is n minus 2. So that would be 9 times delta n minus 3. Okay. Similarly, you multiply this and add the delays of these impulse responses. Multiply the amplitudes, write these delta n with respect to the delays. Add or subtract with respect to the n plus or minus signs. So this would be 6 times delta n minus 4. And here you have 4 times delta n minus 2. And you have here 4 times delta n minus 3. And here you have 12 times delta n minus 4. And here you have 8 times delta n minus 5. Okay. So you people know how to take the origin, right? So we have origin here at 2. Check to the left. To the left of that you have only one term. Here to the left you have 0. So your origin would be at second term. We don't know what is that second term. Let us check. Okay. So origin would be at the second term. So now we have got these things. Now wherever you have delta n plus 1, add those. We don't have any delta n plus 1 term. We have only one delta n plus 1. So that would be delta n plus 1. So check delta n term. You have delta n plus 2 times delta n. That's all. So you have plus 3 times delta n. And n minus 1 terms you add. Where are n minus 1 terms? You have 3 times delta n minus 1, 2 times delta n minus 1, and 3 times delta n minus 1 here. So that would be 8. 8 delta n minus 1. Next you check n minus 2 terms. You have 2 times delta n minus 2 and 6 times delta n minus 2 and 3 times delta n minus 2 and 4 times delta n minus 2. So that would be 15 times delta n minus 2. Okay. Next n minus 3 terms you check. Here we have 4. 4 plus 9 plus 4. Okay, that would be 17 times delta n minus 3. And n minus 4 terms are 6 and 12. So that would be 18 times delta n minus 4. And n minus 5 terms is only 1. So that would be 8 times delta n minus 5. So you have got it in the terms of delta n plus 1, delta n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. So you write 1. What is amplitude here? 1. This is 3. So delta n means it is present only at n is equal to 0. So this would be your origin. Okay. Then 8, 15, 17, 18 and 8. Okay. So this is your convolution using that property. Got it, everyone? You can check them, verify using that simple method also. Got it?
Yes, ma'am.
You have any doubts? You guys have any doubts?
Ma'am, show that final answer.
Yeah. You can do that simple method and verify. I'll give you a few problems, okay? You try that. We'll check that in tomorrow's class. Tomorrow I'll take at 8 o'clock. Okay? So tomorrow at 8 o'clock we can verify. I'll give you problems, take down those problems. If you have understood this one, I'll give you some 2 to 3 homework problems on like this. You try solving like this. Multiply each sequence and convolve it. Okay? Understood, everyone? Is it clear?
Yes, ma'am.
Okay, I'll give you few problems. You take down that, and you do using this like this only. Shall I dictate that? I'll dictate that problem. You please take down. Okay. Will you take down? Shall I dictate?
Yes, ma'am.
So you take
Yes,
down h of n, which is equal to u of n minus u of n minus 10. Okay. If possible, I'll type it here. It's h of, sorry. Yeah, h of n is equal to u of n minus u of n minus 10. U of n minus u of n minus 10. Okay, and x of n is given to be u of n minus 2 minus u of n minus 7. X of n is given to be u of n minus 2 minus u of n minus 7. Okay, so this is the given sequence. You convolve this using that method. Property method, you try to convolve this and you have to tell me the answers tomorrow. Okay, this is the first question. Second question you take down. And one problem I had written in that whiteboard, no, you try that. Simple problem I gave you, no, that you try using this method and verify the answer. Next problem you take down. X of n is equal to 1 comma 1 comma minus 1 comma minus 1. So for this origin is at n is equal to 0. Okay. So at x at 1 first value, origin is at n is equal to 1 first value. Okay. And h of n I'll give you. H of n is equal to 1 1 yeah 1 1 1 1. Okay, so this for this origin is at n is equal to this second value. Okay, second one. So for this it is at first one. For this here it is at second one. Okay, how can I tell? N is equal to. Did you guys follow this origin?
Yes, ma'am.
Yes, ma'am.
For this x of n is at n is equal to 1 first value only. Okay, for this h of n origin is at n is equal to this one second one. Okay, I'll put some transpose or something. Origin is here for this. Try to convolve these two. For these you will know x of n and h of n. So it's given already. So it will start from n is equal to 0 for both x of n and h of n. So these problems you try solving. Tomorrow we'll verify and we'll see some more topics. Got it? Will you try?
Ma'am, both
Or you
using
can try
that
now only.
property method, which
Yes,
is shown in
property
PDF.
method only. Yes, this one.
Okay.
Try solving this and that example problem which I had given, which I had written at the last. And you verify using that simple method. Tomorrow I'll take at 8 o'clock. Okay. You take down these questions and you have to solve it. 4 questions you take. This is one question which I have written in chat box, 2 questions, and one you take that simple method. Any other doubts you have?
Ma'am, for first problem, should we find first finite values and then apply property, ma'am, or through graphical method only should we do, ma'am?
No. Which one? This one. U of n minus U of n minus this one.
Yes, ma'am. Yes, ma'am.
Don't do graphical method. You do this method. What I taught you now. Property method you do.
Yes, ma'am. For that only.
Property
first,
method you do.
get that values, no, ma'am.
Yeah. What is h of n? It will be from 0 to 9. Correct.
Yes, ma'am.
Ones. All ones from 0 to 7. 0 to 9. H of n. Correct. What
Yes,
about x of n? It will be from 2 to 6. Correct.
Yes, ma'am.
Ones. All ones from 2 to 6.
Yes, ma'am.
So try using this property method. First you try to get these values. First plot this u of n minus u of n minus 10. What is the amplitude you take and you do.
And
For this
where,
origin is at n is equal to 0 only. Yes?
for x of n, ma'am, where we should take origin?
From where will the signals, 1 minute. It is u of n minus 2 minus n minus 7, no?
Yes, ma'am.
So at 0, what is the waveform?
0, ma'am.
What is the 0 only? So take origin at n is equal to 0 for both.
Okay, ma'am.
Okay. So what is x of n? 0 0 1 1 1 1. Correct?
Yes, ma'am.
0 0 1 1 1 1 1. That is your x of n. H of n is 1 from 0 to 9. This is 0, 0, 1, 1, 1, 1, 1 till 6. From 2 to 6 you have ones. From 0 and 1, for 0 and 1 you have zeros. Origin is at n is equal to 0 for both.
Ma'am, you have
Any other
given two
doubts you have?
questions to solve.
Yes?
You have given two questions, no, ma'am, to solve.
You solve this one and this one, and that simple method what I've done in class, that you solve using this method, property method, and you solve this also, which I'm showing you. 1, 2, 3, 4, 1, 1, 3, 2.
Yes, ma'am.
Got it?
Yes, ma'am.
So we'll verify tomorrow. Okay? You verify using that simple method also. I'll also do it tomorrow. Anything else, guys? You have any doubts? It's clear? Is it clear, everyone?
Yes, ma'am.
Yes, ma'am. Okay, guys, so we can wind up this session. Write your name and USN in the chat box. Tomorrow I'll take it 8 o'clock. 8 a.m.
Thank you, ma'am.
Thank you, students. MATLAB, whenever you give me, if you have any free classes, you give me, okay? I'll teach you MATLAB.